Our title is on the board. Our title says, how would you determine the biggest rectangle? Go ahead and write that down, please. What are some things that are rectangular shaped? Rectangular. Smile with something that's rectangular. What? The board? Yeah, the board is rectangular. What else is rectangular? Alright, what's something else rectangular?
I don't know. This sheet of paper.
Paper is rectangular, sure. Marley, what else is rectangular? Yep, we already said that one. Can you come up with something else? The bulletin board, sure. Lydia?
The top of our desk.
Top of your desk is rectangular. Jordan? The ceiling is rectangular. Julian? Yep, we already said that one. We gotta come up with something different. Alright, Julian, I'm gonna come back to you, okay? Be ready. Cole?
The American flag without the bull.
The American flag is rectangular. Callie? The mailbox is rectangular. Ava?
The floor table.
The floor table is rectangular. Avery?
Your end picture.
My picture frame is rectangular. Julian, you got another one? The wobble stool table is rectangular. Out of these things, how do you determine which one is the biggest? Oh, sit down. Thank you. Out of the things that we listed, how do you know which one is the biggest? What are some things you might look at? Emma?
The ceiling.
No, I'm not asking what is the biggest. I said, how do you know which one is the biggest?
You can know which one, like, you can look at it and compare the sizes of it.
Okay, so I hear Emma saying we're going to compare the sizes. Jordan, thank you. How might I look at that?
You can look at it and see, see what its features are.
Okay.
How big its size are.
Well, how big the sides are. All right. Cole, what are you thinking?
Length and width.
All right, so maybe we need to pay attention to the dimensions, the length and width. Jordan?
You can use where units and measure.
Sure. Now, a lot of you would probably agree that the ceiling was probably the largest thing listed, but you didn't have to measure the ceiling. So how did you know that? Nobody got up and measured the ceiling or measured the board. So how did you know that out of the things we just shared out, that the ceiling was probably the biggest? Ava, how'd you know that?
So imagine you set the board by the ceiling. The ceiling would probably be bigger because if you look at it, it's literally bigger.
Okay, so I'm hearing we can compare. I'm writing, that means you're writing. Ava, you're talking about a strategy called overlapping. Ava said if I imagine taking my whiteboard and sticking it on the ceiling, I can imagine that the space left over would prove that the ceiling has more space. Has more space. Does that remind you of anything?
Personal space.
It does remind you of personal space. Ava?
It reminds me of area.
Yeah. We are comparing the amount of space, I'm writing, that an object has. Ava gave us a really good tool, thinking about them overlapping, because we know the shape that has more space is going to stick out. know that this piece of graph paper is smaller than a whiteboard, and I can prove it because if I put that paper on top of the whiteboard, look at all that extra space around the whiteboard. Connor, what's that? Will we put in that rule? Now, Cole gave us an interesting thought. He said the dimensions. And you're absolutely true, Cole, sometimes. If they are very obvious dimensions, right? Let's say I had, you do not need to write this versus this. You can obviously tell which one is bigger. But what if, come on now. What if I had that shape versus that shape?
Rectangle's bigger. Yes, it is. What about the width? If you put it into a square, it would be a bigger square.
But the width.
The width?
Because the other one is bigger.
Yeah.
No wonder.
So we are going to look at some rectangles, and we're going to decide which ones are larger, which ones are bigger. They have the bigger area, the biggest amount of space that they take up. These are the rectangles we're going to be looking at. I'm going to give you this piece of paper as well. All right, Emma. You listening to Emma? You think the same thing? I want a Me Too signal. Emma, which rectangle do you think has the largest area?
I'm gonna say that rectangle A.
Rectangle A. I saw a lot of Me Too's on that one, but I also did not see Me Too. So if you said something different, just raise your hand. If you think a different rectangle is the largest rectangle. Marley, which one do you think?
Rectangle F.
F. Anyone else think F? Alright. Any other different ones? Addison?
With the width, I think rectangle C.
C.
So what?
C could be.
Now,
Now, right now, it's a little hard. Absolutely not. It's a little hard to tell. I'm going to give you some tools to make it a little easier. What tools do you think would make this a little easier? What tools might make this a little easier? Avery? Why do you think a ruler would make it easier? Yeah.
It would make it easier because instead of us drawing blocks, it already had that. All we had to do was line it up and then it showed that.
Okay, so Avery thinks maybe a ruler. What else might be a tool that would help you figure out which one had the most space? Julian? Oh, how could you use square units to figure it out? You got it, Julian. Keep going. I am going to give you some square tiles. Put it up. Thank you. Now these are smaller square tiles because the square tiles we have been using are technically square inches. If you were to measure these, Avery and Cole, they are 1 inch by 1 inch. Turn and look at me. That's a good way to show me that you're paying attention. We're going to get smaller units. Put them back.
I don't know. I just found it in my bed.
Then it's absolutely mine because I know you didn't bring it to school.
I didn't bring it to school.
Today, we're going to be using the bits from base 10 pieces. These are square tiles still. However, these are centimeter square tiles. So these measure 1 square centimeter. Yes. They are because they're cubes. But you can still use them. These are pretty cute.
Oh, yeah. You did it.
Callie?
Are we measuring the weight or how much?
Ooh, I I just heard a fantastic question. Turn and look at me. Allie said, with these square tiles, are we measuring the width or the length? What are we measuring? What am I going to use these for? It's a great question. Cole, what are you thinking?
Both.
Why do you say both?
Because we need to know how long both. I mean, we need to know how big both are.
So if you figure out the width and the length,
You know the area.
could you figure out the area?
Yes.
Yes. So you're going to need to measure both the width and the length to help you figure out how many square tiles would fit in all. When I give you your square tiles, you may get started.
A bit of a spot.
1, 2, 3. Eyes on me.
1, 2, eyes on you.
Hands off your pieces. Hands off your pieces. Alright, most of you, Connor's are reading or following my directions. Most of you started with rectangle A. And I saw a lot of you starting to put your pieces right up to make a row at top. About how many fit there? About how many fit there? Art?
5.
5. Now Art said 5 with this gesture. He said 5. Art, why did you do this?
Because it can't really, there's a bit of a spot missing, but if I put it there, then it would overlap. So there's really nothing that I can do.
Yeah, so Art is already thinking it's 5 plus a little bit. It looks like this. And then this little bit, Art noticed I can't put a tile there because it's really half of a tile or a part of a tile. That doesn't mean that we don't measure that, but Art's thinking and it said, okay, I have a little bit more. Did anyone measure going down this side, this dimension to make our column? Did anyone measure that part? You should not be touching your pieces. Rogan, you measured that? How many pieces, how many square tiles did you take to go down that side? Is it 6 exactly, or was there some space? Let's go ahead and do that. If you have not put your square tiles measuring the length of A, go ahead and do that, please. Lydia?
6 and like a little bit more.
Okay. I've got 1, 2, 3, 4, 5, 6. I know it's going to be a little bit more than that because I've got a little bit of space. Stop touching your pieces. Eyes up here. If you know that this dimension is 5-ish, and this dimension is 6-ish, about what is the area? So we know that it's going to be more than whatever you just counted because we've got a little bit here and a little bit here. But ish, what is the area? What is close to the area? Stop touching your tiles. Julian?
30.
How did you get 30?
So I counted 5, and I counted 5, 6 times.
Beautiful. Julian said 5, 10, 15, 20, 25, 30. Would that get you your area? All right, we know with your pencil, we're going to do this symbol. We haven't talked about that symbol a lot, but remember when we talked about that symbol meaning about? That was our estimate symbol. Looks like a squirrel. With your pencil, you're going to write about 30 square units, or you could put cm for centimeters. I want you to measure and see if you can figure out the area of rectangle C. When you've got it, give me a secret thumb. Go. How'd you figure it out for rectangle C? What were you doing? Even if you didn't finish, what were you working on? Colby, what were you working on? How could you solve it, Colby? What were you doing?
Throwing a square. Putting squares on the side.
Okay, did that square fit exactly? No, so there's a little bit left over. Did you figure out how many total squares it went all the way down? How many? 11. Did anyone else get 11? How would you get?
I got 10.
10? Double check that you're not hanging over. There should have been a dimension here of 10.
10 with a little bit more.
And then 1 up here, which meant our area was about 10 square units. Which area so far was bigger? We've done 2 areas. We did rectangle A and rectangle C. Raise your hand and tell me which one was bigger. It's not a trick question. Maya? A is bigger. A was 30 square tiles, square units, versus 10. Now, we expected that poll because no one said, I think C's the biggest. No one said that. But some of you thought maybe F might be the biggest.
No.
Let's see if F is bigger than A. Go ahead and use your square tiles on F, please. All right. What was our width? What was the width? We're going to say this is what I'm talking about right here. What was the width of shape F? What was the width? I'm waiting until I see everyone's hands because I know everyone did this. I'm waiting until I see everyone's hands because I know everyone did this. I'm waiting until I see everyone's hands because I know everyone did this. Penelope, what was the width?
The width was 2.
Exactly 2? So 2 plus a little bit. Okay. With your pencil, label the width 2 units. Penelope's right, not exactly 2, but we're still going to write 2 units. What was the length? What was the length, this dimension? I'm waiting until I see everyone's hands because I saw so many people do this. Cole? No. Cole, what was the width?
2. A little bit more.
Oh, sorry, that's not the question I meant to ask. What was the length?
9.
9. Was it exactly 9?
No.
Oh, was there a little bit more?
Yeah.
With your pencil, label the dimension or length for 9 units. If you know we've got a 2 by 9, what is the area? You've got a 2 by 9. What was your area? Lydia?
About 18.
About 18 square units. So is shape F bigger than shape A?
No.
No. Did anyone else think a different shape might be the largest? I know a lot of you thought A, and I saw some of you think F. Was there any other shapes that you thought might be bigger, Brogan? G. Let's measure G. This will be the last one that we measure.
Another square.
Go ahead and measure G. See if G is bigger than A. All right, let's go through our dimensions. Cole, turn around, please. Raise your hand if you found the width. Raise your hand if you found the width. Maverick, what'd you find? Yes? 5, exactly? Exactly 5. Cool. 5 units. Go ahead and write it down. Rogan, we're listening to the words I'm saying. Callie, we're listening to the words I'm saying. What was the length? What was the length? What'd you find for the length? What'd you find for the length? Avery?
25 square units.
Nope, that is not the length. That was not the length. She just wasn't listening to my question. Avery, what's the length?
5.
5. 5.
She's very 5 square units.
No, square unit.
5 units.
Just 5 units. Because when we use them to measure the inside, we get an area of about what, Avery?
25
So, was G larger than shape A?
No.
So the largest shape on here is shape A.
They're small.
They're going to be smaller than shape A. You are decorating bookmarks to sell. You want to cover some of the bookmarks in glitter. How much glitter will you need? This doesn't have all the information. Stop while I'm talking. Stop while I'm talking. You don't have all the information here. You're missing some information. What do you need to know to answer that question? It says you're decorating bookmarks to sell. You want to cover some of the bookmarks in glitter. How much glitter will you need? You're missing some information. What is some information that you need? What do you need?
How many bookmarks do you want to cover in glitter?
We might need to know how many bookmarks we're going to be covering. Because one bookmark versus 100 bookmarks is going to be different. Marlon, what else are we going to need?
How many bookmarks are there?
That's what Jordan just said. What else might we need to know? Lydia, what else might I need to know?
How many bookmarks are putting glitter on?
How many bookmarks am I putting glitter on? It might not be all of them. What else do I need to know? Maverick, what else do I need to know?
How long what is it like the width of the bookmark?
Ooh, what's the dimensions of the bookmark? What if they're really long and skinny, or what if they're really short? That's going to affect my glitter. Alright, is there anything else I need to know?
What's the length of how much glitter you have? Like,
Oh, I think I know what you're saying. I'm going to ask this. Is this what you mean? Are they like big glitter or little glitter? Is that what you're asking? Yeah, because glitter can be different sizes. Sometimes you got big old glitters. And sometimes you got little tiny glitters. Glitter pieces. I don't know what those are even called. Callie, what might be some information I need to know?
like, I don't know what to say, but like, are they talking about how much lines of glitter you need, or how many bottles?
We don't know. That could be also something to know. I'm going to give you some information. You're decorating some bookmarks to sell. You want to cover some of the bookmarks in glitter. Your bookmark is 4 centimeters wide and 12 centimeters long. How much glitter will you need? We're going to say to cover one. To cover one. answered that problem and write an answer sentence in your notebook. Raise your hand if you've got an answer sentence. Raise your hand if you've got an answer sentence. Colby, you still working? Ah! Connor, what answer sentence did you write? We need a little bit more, but that's really close. You need blank. What am I measuring my glitter with? Because I have a feeling, Connor, I'm not using miles of glitter. Am I using miles of glitter? So what is the measuring unit that I'm using? Centimeters. You need blank square centimeters, because that's what I'm counting, of glitter. If you've already got a sentence, but it doesn't have square centimeters, then your sentence is not correct. Because we need the unit that we're using. Feet of glitter is very different than centimeters of glitter. The pieces we used this morning were centimeters. Think of how small that was. So it's very important that we use square centimeters. The next step is I need to draw what's happening. What shape usually is a bookmark, Colby? I'm going to draw a rectangle. Draw a rectangle in your notebook. Julian, I've got the dimensions in my problem. What are the dimensions of my bookmark? So we should probably look at our problem. It tells us in that word problem. Yeah, 4 centimeters wide. That's how wide it is. Kelly, how long is our bookmark? 12 centimeters. So we know how wide it is and we know how long it is. Now what do I do?
You draw.
I'm going to draw all those squares.
Fast ray.
Ooh, love a fast ray. I'll go ahead and draw my 4 here. 1, 2, 3, 4. And then I need 12 going down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That will squish down at the bottom. So far, so good. This looks just like when we used our pieces. But now what do I do? I am not going to draw the rest of the boxes. That's not what I'm going to do. How could I solve that if I'm not going to draw the boxes? Lydia?
You can break the 12 into 10 and 2 and then count 10 4 times and then add 8.
Okay, so Lydia's saying I'm going to break my 12, so now I've got 10 centimeters here, and then, and then 2 centimeters here. Do you see how I did that? So now this first chunk, I have 4 by 10. Lydia, did you do that because it's easier to count by 10?
Yeah.
What is 4 tens worth? What is 4 tens worth? Because Lydia said, you know what, I'm going to skip count, but instead of skip counting by 12, I'm just going to do my tens first, because that's easy. So there we've got 10. Keep going.
20, 30, 40.
All right, so this piece right here is worth 40 centimeters. Ooh, square centimeters. But wait, Lydia chopped it up. She chopped it up. We can't forget about this bottom piece. We've got 2 by 4. So
Another 2 by 4.
what is that going to be worth?
2 by 4 plus 2.
What is 2 fours? 2 groups of 4. What is that worth?
8.
8. So this section down here is worth 8. Oh, I did it again. Square centimeters. We know our unit. It's the centimeter.
8.
So now that Lydia chopped it up, if we were to think about it still all together, what would be my total area? What would be my total area? Avery?
48 square centimeters.
48 square centimeters. Now we did already solve this, but I want to write down the equation so you know what the math language looks like. Connor, turn around. So Lydia used 4 groups of 12. She was going to skip count. She just realized, Callie, that skip counting with 12 is difficult, so we're going to chop it up. No, thank you. You don't get to decide what's difficult and easy. Callie, we're writing, baby. 4 groups of 12. Some of you might have said, okay, 12 plus another 12 plus another 12 plus another 12. That's another equation you can use.
That's what I would do.
Love it. Could you have done it by 4s? Could you have gone this way?
4. Yeah.
How many 4s would that be?
12.
12 groups of 4. Could you have done that?
Could you,
4 times 12?
Yeah.
Connor?
what I would do is I would do 10 plus 10.
Awesome. Avery?
Well,
Okay, we've got one more piece we're going to work on right now. Madison was trying to figure out how much glitter she would need on her bookmarks. The ones we just did, 4 centimeters by 12 centimeters. But she said she would only need 16 square centimeters. What did she do wrong? Oh, we're not yelling our thoughts out. So the correct answer is on your paper. It is 48.
yeah.
But Madison got 16. What did she do wrong? I'm just going to redraw our model so it's on this page.
You don't need
Again, we had 4 centimeters by 12 centimeters. We have 12 in our 4.
Stop.
Sit down. I have seen 3rd graders get the same answer. What mistake did Madison make? I'm giving everybody a chance to think.
You're right.
Cole, what do you think Madison did?
She had 12 plus 4 instead of 4 times 12.
Oh. So she just added up this area. But did she do anything with this area?
No.
No, she kind of forgot.
Stop.
I see this happen a lot. Remember, when you're adding, that's just literally the pieces that you labeled. We are skip counting. These are skip counts. These rows exist even if we can't see them. next blank page, and I'm going to give you your new math whiteboard.